6. Happy Thursday. Welcome to Lesson 2 in Science. We spent the last 2 days talking about identifying minerals and rocks, all the different characteristics that minerals have, and then the 3 types of rocks and how they cycle through. We ended yesterday talking a little bit on the evolution side on how scientists believe they're super old layers like that, and of course they go to millions and billions of years, guys, because that's in their mind what it would take to create, let's say, the Grand Canyon with all those different layers that they see, on how long that would take them in their mind, guys. So what they're doing is just they're using their brains, and they're saying if it would take hundreds and hundreds, thousands and thousands of years to build up enough sediments and cement them together in a layer of rock, and we have all those layers, they instantly go to million. They don't believe in a flood, guys. They don't believe in a God or creation, and so they just try to explain everything with their brains. We obviously believe in a God and creation and the flood and things like that, so all those things could have been either created by God or caused during a flood. But you got to be able to take that in stride and understand where they're coming from, and then make sure your faith is rock solid and say, I believe in creation or an all-powerful God. Today we're going to talk about making soil and understanding why soil is so important to living things. The summary paragraph says this: soil is made of weathered rock, air, water, and the remains of living organisms. Almost all land-dwelling organisms depend on soil for life. Plants obtain water and minerals from soil. Animals need plants for food. Insects and many other small animals live in the soil. So do fungi and bacteria that are even too small for us to see. And so what we're getting at today is, man, soil is obviously super, super important. Without soil, you and I would be dead. It keeps the processes of life going. You got your notes. We're ready to rock and roll. You don't have your notes yet because I have the wrong notes up. Oh my goodness. Easy extra credit. There you go, right on the top. Started with history notes instead of the science. You might recognize that history note page there tomorrow. Sorry about that. Okay, now we're ready to rock and roll. The rock cycle isn't the only process that rocks are part of. They are also part of the process that forms soil. New soil begins when exposed rocks begin to break down. You have number 1 in your notes. So I have rocks on the soil and they break down. Let's learn how they break down. This process is called weathering. Okay, so weathering is the breaking down of rocks. It can be caused by physical factors such as frost, drought, or changes in temperature. We see those changes in temperatures a lot, guys, in the springtime. You think about our roads and how they get potholes. That's changes in temperature. I have snow on the roads in the spring, right when the winter is going away. The snow starts to melt. It gets in the little cracks in the road because it's 35 degrees out during the day. Then at night it drops to 20 degrees. What happens to that water? It freezes. When it freezes, it expands. When it expands, it busts our road apart, okay? So changes in temperature can do that. It can also happen sometimes in really hot temperatures. It can get so hot that it causes it to buckle. Why? Because when roads get hot, they expand, and if there's no place for them to expand, they literally crumble. Okay, that's just all physical, guys. Rainwater and the substances dissolved in it also can break down rock. As weathering occurs, you should have got number 3, sorry, with that one. Okay, so you need substances in there. An example of this, guys, is if you look at our railings outside our school now, we put new cement by them. Why? Because the old cement had broken off because of the substances dissolved in it, caused it to rust, weakened the rock, the cement, and it broke. As weathering occurs, rock is broken down into smaller and smaller pieces. Air and water fill the spaces between the pieces of rock. The tiny particles of rock, along with the air and water, are the non-living, or what we use, inorganic part of soil. So you got a few things that are going on there. Number 4 in your notes, inorganic means the non-living part of soil. Now go back, and that's air and water into your notes, and then the tiny pieces of rock. Okay, so inorganic, remember, never alive. We're going to talk about the other part of soil being everything that is alive. So they give you the process here, guys. We start with this rock. We start breaking it down into smaller and smaller pieces. Then we're going to start to add plants. I'm just going to read this because this will be part of your test. As rock breaks down, small pieces collect at the surface. Mosses and lichens are the first plants to grow. They break down more rock, helping to release minerals. Soil then begins to form. So these mosses that'll live on, like the rock guys, are starting to break it down with their roots. As weathering continues, more soil forms, larger plants appear. Dead plants and animals create humus, which provides nutrients for plants. So step one, these plants help break it down. Step two, they're eventually going to die, and that adds nutrients. So they toss out the word humus. We're about to read what humus is. I'll just finish to number 3 here. A mature soil is home to many kinds of living things. This soil is rich in organic matter and contains many plant roots. So you can see it gets thicker. So here, guys, not that much soil until we hit what we call bedrock down there. This one, the bedrock, is obviously deeper and farther down, and plants can get at it. All right. Over here, as time passes, bacteria, fungi, and plants begin to grow among the particles. When these organisms die, they rot or decay. This gives us organic matter. Organic matter is any substance that is made of living things or the remains of living things. You have number 5 in your notes. The dark colored organic matter formed from decayed plant and animals is called humus. Okay, so you got number 6 in your notes. It's the dark part of soil, guys. If you looking at that, it's any substance that has it is organic matter. This is the dark stuff. So guys, one of the ways to look at it is a leaf falls to the ground. Okay, that's organic material because it is the remain of a living thing. That leaf actually decays and churns into nutrients. That's humus. So to tell the difference between these two, this is anything, obviously. This is the good stuff at the end of the decaying process. Humus is the organic part of soil. It's rich in nutrients. This is the best of the best, okay? So I usually put it as a scale. Humus is an example of organic matter, but organic matter is everything. Humus is the good stuff. All right. Cruising on. Soils form in 3 layers, which can be seen in a soil profile. A soil profile is a vertical section of soil and the rock underneath it. It reveals what is inside the soil. So as you're cruising along, and you have number 8 in your notes, you need 3 layers. If you're doing a really good job proofreading right now, you'll circle the word is. It says soils form is 3 layers. It should say the word in. Soils form in 3 layers. So make sure you circle that as you proofread for Mr. Bauer there and say, you did that wrong. Okay, when they talk about a soil profile, guys, it's like literally just drawing a rectangle here and chopping it into 3 layers and saying top layer, middle layer, bottom layer, and then they have names for those. Let's go through it. Each layer of soil has a different structure and color. The first layer is called topsoil. It is a mixture of small rock pieces, fill in your blank with humus, and other organic matter. Most of the living things in soil are found in topsoil, and loose organic matter such as dead leaves and twigs often cover the topsoil. Okay, so I add in here, you have to get the word humus. You want good topsoil, guys. This is where we grow everything. Rainwater sinking into the topsoil carries minerals down to the second layer. The second layer is called subsoil, so you want the word second here. This is the second layer of soil, and it is not going to be as good, but it's still useful. Subsoil has less organic matter, and it is lighter in color. So sometimes, guys, you can just tell what kind of soil you have by looking at it. Rich, dark, black soil is really good topsoil. Wisconsin has that, guys. The farming fields have a super rich, dark soil. Underneath that's going to be not so great, so it's lighter in color. Minerals carried away from the topsoil builds up in the subsoil. Your triple I here. So some of the minerals by water drains it down and gets into it, which would sound like a good thing, guys. It's just that plants don't get down that far, and neither does a lot of the humus, because the decaying leaves and things stay in the topsoil. The third and lowest layer is made up of what's called parent rock material. There is very little organic matter here, so I just wrote down parent rock, the lowest layer, very little organic matter. Obviously not much is growing there, guys. Sometimes you hear this called bedrock. Down here where you get to solid rock. When we build huge buildings like skyscrapers, we want to get the foundation down here into bedrock. Dirt can shift and move. Bedrock, absolutely solid. Okay, so you got how soil forms, guys. Takes a long time, hundreds of years. Let's continue on and talk about the different kinds of soils now as we finish up our notes. Most of us think of soil as dark brown and crumbly, but there are many kinds of soil. Clay soils are fine-grained and hold water extremely well. Number 10 in your notes. When rainfall is plentiful, clay soil will become waterlogged. Type of soil number 1, clay. Type of soil number 2, silt soils have medium-sized grains. Thus, holds water too good, doesn't hold water good enough. Yay, perfect. Thus the word silt in ancient history and where we get it for farming. Sandy soils are large grain and hold water poorly. So guys, you got 3 types of soils. Holds water really good, holds some but not all of it, and doesn't hold water enough. So you think about sandy soil, guys, if I'm at the beach and I'm building my little castle and I have my little, ditches that I put water in, and I run to the lake and I pick up a bucket of water and I dump it in there like, hey, there's water, and then it's gone. It just goes right through it, right? I can't get it to stay. Okay, clay, what do we do with clay? Clay we make into vases, guys. That's pottery today because it can be so finely packed together that it literally holds all water, doesn't drip through at all. Okay, most soils obviously are a mixture of all 3 of these. Loam is a type of soil that contains silt and sand in roughly the equal amounts. So number 13 in your notes, guys, it has all 3, but it has silt and sand in equal amounts. Now, I don't want you to think it's 1/3, 1/3, 1/3. You're going to see coming up that it's not even close to that, because what we're doing is, you got to understand, soil is not just these types of dirt. It's also that humus, that organic material, air, water, and all kinds of other things that go into it. All right, let's see what makes soil soil. The climate of an area may be the most important factor that determines the type of soil that forms. The weathering that breaks down rock to form soil takes place more quickly in climates with a lot of rainfall and warm temperature. Okay, so I wrote down climate. Warm and a lot of rain weathers rocks. You want the word quickly there. So that's going to give me more soil. In tropical climates, the plentiful rainfall washes minerals out of the topsoil into the subsoil. The result is that the tropical topsoil is very thin and it's not very good because all the mineral gets washed out. If you remember that from chapter, I think 6 was the biome chapter, and we talked about tropical rainforests. Soil's not that good on top because there's so much rain it pushes it down to the next layer. In contrast, desert areas receive very little rain, so weathering is slow. Okay, so if you're breaking it down in your notes over here, we had weathers rock quickly, pushes it into the subsoil for letter I there, and I wrote down for desert, little rain equals little weathering. Or little rain equals, went with this word, little weathering. You might want to say little soil. It just does not that good. So I wrote down little weathering because that's in the page right there, but it's not going to be able to make it because there's not enough rain. The little rain that does fall evaporates quickly. Therefore, minerals that were dissolved in water collect on the soil's surface. The type of soil that forms also depends on the kind of rock from which it forms. The kinds of minerals in the rock affect the characteristics of the soil. For example, reddish soils come from rocks with iron-rich minerals. The minerals also can affect the weathering process. So you want over here, for letter B, what rock breaks down is the kind of mineral. So if it's red, it probably comes from iron minerals. Other things that help soil that we need to remember: worms. Worms eat through soil and they digest the material and pass their digestion right back into that. So the more worms you have, the better the soil is. Peat is partly decayed plant material that has been buried and compressed in a swamp. When dried, peat can be burned as fuel. We'll talk about that later on, guys, and then chapters coming up on how we get, what am I doing? Hang on. What? Stop. Oh my goodness. There we go. Sorry about that. Let's finish it up here. I'm going to finish with the paragraphs. We'll finish the notes. Soil color is also affected by the amount of organic matter in it. Soil with more organic matter is darker in color. So the darker the soil, the more organic matter in it. We talked about that already on the last page where I came up here and we had the darker colors with that. Forest soils in the eastern United States have a lot of humus and are dark brown. The many leaves that fall from the forest trees every autumn helps form the humus. So guys, that's true in east United States, that's true in Wisconsin. We talked about that also in the biome chapter. The decaying leaves and plentiful rainfall form a thick, fertile soil. Tropical soils which have little humus are lighter in color. Another factor that affects soil formation is the shape of the land. Mountains obviously have thin layers of topsoil because much of the soil just erodes down the slope. Land that is flat will have usually thick layers of topsoil. So mountains, thin, flat land, you want the word thick there. Obviously, you live in the Great Plains. We have good soil that goes along with it. Okay, guys, remember loam was about equal parts silt and sand, and so you can see this diagram is absolutely perfect. When I think of dirt, I think of it's all dirt, but less than half of it, guys, is literally the dirt part of it, the three types of soils we talked about. Then you have the once living stuff, 5%, and then you have all the air and the water that's mixed in there. So this was the perfect, so that you understand equal parts silt and sand, but keep this in mind, all the other stuff that goes along with it. Okay? We're not going to even barely mention this. This is talking about a timeline and how to show you things are billions and billions of years old, so you can see how long it is, and it's not very good thing to talk about. Okay, and then how we end it with our math and science section is just the only reason I wanted to show this again was to show you once again the breakdown of they took their minerals, guys. So if you go back to this up here that we were just talking about with loam, if I can scroll this right without messing it up, we had those three types of soils. They took that in this thing down here and they put it together and they called that's the minerals. And so it's the same exact chart, 25%, 25%, 5% organic, 45% of the types of soils. Just a thing for you to be able to keep in mind as we work our way through that and understand it. Awesome, guys. That brings us to the end of lesson 2. You got the worksheet that goes along with it. Take your time on that true false section, and then tomorrow, rock on, you'll be ready for a test. Have a great day.